Okay, so we're going to be having a look at some different types of equations today. And I've called these harder equations because really what's happening here is there's just a slight change that the angle is no longer going to be just theta or just x. It's then actually going to become a linear expression. So I'm just going to sort of mention something here that the angle that goes inside the cos or the sine or the tan, the angle that goes inside that, I'm often going to refer to this as the argument. And the argument just means the input into a function. And the reason I wanted to introduce this phrase or this word argument is just because it's often a little bit easier to explain some of these things rather than saying the angle, because it can sometimes be a bit confusing. So here we would say that the argument is 3x, and usually we've only been able to solve these equations when we've just had something like cos x or cos theta. So there's a few different steps that you need to take in this kind of question. So if we're trying to solve this equation, it's worth noting that we want it to be cos of 3x equals minus a half in the interval 0 to 360 degrees. But notice how this is x and the argument is 3x. So we have something that doesn't seem to match. Well, let's have a read through of what our steps over here tell us. So it says, step 1, adjust the range of values for theta, or x in our case, to match the expression inside the cos. The expression inside the cos, that's what we call the argument. So the argument here is 3x, but the range is only x. So we're going to change that range. Well, the initial range is that x is between 0 and 360. And we want to change it so it matches, so it is 3x. Well, this is just an inequality here. So if x has gone to 3x, we've multiplied it by 3. So we will have that it is between 0 and 360 times 3 is 1080 degrees. Now you'll see why we're going to need to do that, and I'm going to explain afterwards about why that might happen, why we need to do this changing of the range. So step 2, it says immediately after applying the inverse trig function and before dividing by 3, find all solutions up to the end of the interval. Okay, so there's a few things in there I'm going to need to explain in just a second, but really what we're going to do now is we're going to take that cos 3x is equal to minus a half, and we're going to actually just start doing some calculations with this. We're actually going to try and find out what 3x is equal to. So 3x is going to be equal to the inverse cos, arc cos, of minus a half. So I've got my calculator still here, very good. I can just keep it out. So I'm going to do the inverse cos of minus a half, and I'm going to press equals, and we get 120 degrees. So one of our angles here that we've got is 120 degrees, and we're going to have to look for another one. Now you should remember for cos it will be 360 minus that answer, and we get 240 degrees. So we actually start off with a pair of values. There's always going to be a pair of values for cos and a pair of values for sine, and then we want to try and find all of the values that are inside our new range that we've got here. So clearly there are going to be a few more for these ones that we have. So I'm going to start off by thinking about this 120, and I'm going to keep adding 360 onto that one. So I've got 120 and I can add on 360, I get 480. I could add on another 360 and I'm still going to be below the 1080. So let's add on another 360 and we get 840. And if I add on another 360, I go beyond the range, so I'm going to stop there. I'm now going to, for the other one that I have here, which I'm going to switch over to a green color, I'm going to do the same process of adding the 360 degrees onto it. So I've got my 240, add 360, and I get 600 degrees. If I add on another 360, I get 960 degrees. And actually, if I go any further, let's see if I add 360, yeah, I'm clearly going to go over the top there. So for the range that I have here, I have now got these 6 different answers that I have. And it's going to make a bit more sense with what we've just done here. It says, immediately after applying an inverse trig function, find all solutions up to the end of the interval. So here was when I applied the inverse trig function, and I have found all the solutions up to the end of this new interval. It said here though, before dividing by 3, because what I've done is I have solved the equation for what 3x is equal to, but I want to know just what x is equal to. So that means I'm going to take all of these answers and I'm going to divide them all by 3 to come up with just what x is equal to. So if I divide all of these ones by 3, I'm going to go this one, this one, this one, this one, this one, this one. Obviously, 120 divided by 3 is 40. Let's see what my other ones are. So I've got 480 divided by 3. That's 160. I've got 840 divided by 3. That's 280. 240 divided by 3 is just going to be 80. 600 divided by 3 is 200. And 960 divided by 3, feeling super lazy on a Monday morning, is 320 degrees. So we've got 1, 2, 3, 4, 5, 6. And I guess normally what we would do here is we'd write them in order. We'd go 40, 80, 160, 200, 280, and 320. So it looks what happened here is we've actually got lots more solutions. And you can see now, hopefully, why we had to make this range bigger. Because when we did the dividing by 3 at the end, we wanted to make sure that they were all inside 360. So as we knew we'd be doing this division by 3 at the end, it made sense to change the range by the multiplying it by 3 at this stage. So I've just added some reflections here. So as mentioned before, in general, you tend to get a pair of values per 360 degrees for any of the sine, cos, and tan. That is unless we're talking about cos theta being equal to plus or minus 1 or sine theta being equal to plus or minus 1. You would only just get one of those per pair. So I've said here, once you get your first pair of values, which I've done in red and I've done in green, using these two things that we have here, to get that second value, you just keep adding 360 to generate new pairs. So they come in a pair like this, a pair like this, and a pair like this. Okay. So for sine and cos, you're always going to have 2 to start off with, and then just keep adding 360. For tan, you'll have 1 to start with, and you just keep adding on 180. So why have we got so many more solutions here? Well, if you have a think about the graph y equals cos 3x, you should be able to tell me what type of transformation this is. Well, if it was the y equals cos x graph, clearly we're now doing f of 3x, and f of 3x is going to be a scale factor of a third in the x direction. So it's actually squeezed the graph in. I'm going to show you what this looks like on Desmos. So if I go into Desmos for a second, and I'm just going to say that y equals, let's do cos x, and then we'll change it to cos of 3x so we can show you what's happening here. So I want to put it in degrees mode. So let me just quickly squeeze this in. So there's our cos graph that we're quite familiar with that we have here. I might just quickly change these so it looks just how I like it. Not quite how I wanted it, but whatever, it's all good. And I'm just going to change it to cos of 3x, and you're going to see how it's going to sort of cram in a lot more. So we've got 3 of these cycles. We've actually got a lot more crammed inside the 360 degrees space. And we were interested in when this graph was equal to minus 0.5. And so we've got, when I zoom in just a little bit further, 1, 2, 3, 4, 5, 6 solutions. Okay, so there are those 6 solutions. We've got 40, 80, 160, 200, 280, and 320. Okay, so if I go back to good notes here, we're going to try another example that we've got, and then maybe I'll show you how to use the calculator as a bit of a reminder for this. Okay, so our interval is that x is between 0 and 360, but this is the interval that we're going to want to change it to. So you could either do it over the side of the page. So I've got 0, x, 360. Now the first thing I'm doing to x is I'm multiplying it by 2, then I'm going to add 30. So first of all, I'll change it by multiplying it by 2. So we get like this. And then I'm going to add 30. So I get 2x plus 30. Whoops, I'm going to add 30 there as well. And then I get 750. So this is when I do the undoing of the argument that I have here. When I undo it later, the range will go back to being the correct range that we are looking for. So I'm now going to just go about solving the equation as normal. So I have that sine of 2x plus 30 is equal to 1 over root 2. So that must mean that 2x plus 30 is equal to the inverse sine of 1 over root 2. Now, you don't need to use a calculator for this, because you should know that the inverse sine of 1 over root 2 is, hope you're telling me, 45 degrees. So the other one that we're going to have is going to be 180 minus the 45 degrees. So those are our starting pair of values that we have. We have 45 and we have 135. And we're going to do the same process as before of taking this one and adding 360 to it. And then we're going to take this one and adding 360 to it. But we're going to be paying attention to this range that we have over here. Okay? So no point in taking away 360 from either of these. I'm going to start off with my 45 and add 360 so that I have got 405. And I need to stop when I get to 750. So there's not much point in adding 360 on there because 765 goes beyond that range that I have. So we're going to do the other one as well. We have 135, and I'm going to add 360, and I get 495. So I have 495 degrees here. Now, obviously, if I add another 360 to this, so if I do 495, whoops, 495, and I add 360, clearly it's going to be too big. So if I now want to find out what the x values are, I will, from these four that I have here, I will take away 30 from them to get rid of this bit, and then I will divide by 2. So I'm going to do 45 take away 30 is 15, and I divide it by 2, so I get 15 over 2, or 7.5 degrees. So let's go back here. So we've got 7.5 degrees. So my next one that I've got is the 135. So I'll do 135, I'll take away 30, and then I'll divide by 2, and I get 52.5 degrees. And then my next one is going to be 405. I'll take away 30, and then I'll divide by 2, and I've got 187.5 degrees. And then I'm going to do it with the last one, which is 495. I'll take away 30, and then I'll divide by 2, and I get 232.5 degrees. So I have 1, 2, 3, 4 solutions here that I've done to 4 decimal places. Well, interestingly, in this one, we had 1, 2, 3, 4, 5, 6 solutions, and our solution, our transformation, had shrunk it down 3 times, which makes sense because normally for a cosine graph, we would get 1, 2 solutions. And if we've squeezed it in, so it's a scale factor of a third, it makes sense that we get 3 times as many solutions. And similarly here, the 2x that we had inside the argument has squeezed it in by a scale factor of half. We would normally expect 2 solutions, so it makes sense that we've got 4 solutions in that same typical range of 0 to 360. So I'm just going to confirm that using my, my calculator that I've got this equation correct. So I'm going to remind us now of my graphics calculator, how we can do some of these things here. So the equation was, let's go back to, so it's going to be options, calc, and solve n, and our equation was the sine of 2x plus 30 is equal to 1 over root 2, 1 over root 2. And I'm going to put my range in, so I'll do comma, x, comma, 0, comma, 360, close brackets, and then just press execute. It's going to say there's a few solutions there. And so they've got these written in fractional form, but I'm going to press execute here so I can see them as a list. So we've got 7.5, 52.5, 187.5, and 232.5. I've got it as this weird fraction thing. I need to change it off that because I don't like that as much. Okay, but you can see them, those other ones that we had. And similarly, you could look on Desmos and see how they went as well. Okay, so let's just go back to Good notes. I'm going to try one more question, and then you're going to have a go at doing one yourself. So this time the argument is a half x, but the range is over here. So I'm going to write my range. Currently my range is that x is between 0 and 1080 degrees, but I want my argument to be a half x. So I'm going to half all of these values. A half of 1080 is 540 degrees. Now this is one of those equations where we need to do a bit of manipulating first. So I have sine a half x equals 2 cos a half x. Well, we know if we have a sine and cos, we're going to want to combine them into a tan of a half x. And a tan of a half x is going to be sine of a half x divided by cos of a half x. So I'm going to divide everything here by cos of a half x, which will leave me with tan of a half x on the left and 2 on the right hand side here. Now I've already changed the range. I'm going to highlight my range in yellow so that we can see what we're actually going to be dealing with. We're going to be going all the way up to 540. So I get here that a half x is equal to the inverse tan of 2. And remember, this is the stage we're going to be finding all of our solutions in that range. So let's clear all of this calculator because it's getting a bit busy. So I'm going to do the inverse tan of 2. And the one that I get here is 63 point. I'm actually going to do a couple of decimal places here because I'm going to be doing some doubling in a second. So I just want to give it a little bit more detail. So I've got 63.43 degrees. Now for tan, you should just remember that you just keep adding 180 to this. So I'm not going to need to use my red or my green pen here. So I get 243.43 degrees, and I'm going to add on another 180. Actually, I like to do that on a separate line. So you get 423.43 degrees, and I'm going to add on another 180, and I go to 603. But 603 is outside of that range, so I'm not going to write that one down there. Now that's what a half x is equal to. So x is going to be all of these values that we have here, they're just going to be doubled, okay? So I'm going to do my 63.43, and I'm going to double it, and I get 126.9 degrees to one decimal place. I'm then going to do my 243.43, and it's going to be 486.9 degrees. And my next one here is going to be my 423.43, and that's going to be 846.9 degrees. And this is why you have to do your pattern of adding on your 180 immediately after having done the arctan or the inverse tan, is because the final ones don't have a gap of 180. The final ones have a gap of 360. So that's why you have to make sure that you follow the patterns from the trig laws that we've done for tan and sine and cos immediately after having done the inverse tan. So let's just check that these are solutions. I'm going to do this one on, I'm going to do it on my calculator. So let's just quickly switch to the camera. Okay. Sorry, there's some teachers outside in the corridor, so it's kind of like, I don't know if they're being noisy or not. I don't know if you can hear it. Okay, so I'm going to go to options, calculate, solve n, and it was sine of a half x equals 2 cos of a half x, and then I'm going to close that off by doing comma, x, 0, 1, what was it between, I think it was 1080, I hope that's right. Many solutions may exist, so let's have a look at these as a calculator. We've got 126.9, 486.9, and 846.9. We've got those three solutions that have come from the calculator there. So very good. We know we've got this correct. 1, 2, 3. Whoops. Okay, so there is now a chance for you to have a go at this question. It wants your answers to one decimal places. Take note of the original range and what the argument has changed to. And then that's going to be enough help for you to be able to do exercise 10E. So have a go at this question now. Pause the video and then I shall go through it in just a second. Okay, so our range that has been given is that x is between 0 and 180, but we want to change it to 3x minus 10. So the first thing we're going to need to do is multiply it by 3 to get the 3x. So 180 multiplied by 3 is 540. And then what I'm going to do is subtract 10. So I get the range is 3x minus 10. I always do this with this bit because I haven't subtracted 10 properly. I would subtract 10 from here and I would subtract 10 from here. Okay, so my equation is going to be now wanting to use this range of values that we have. Just want to check that right there. I did. So we have got the cos of 3x minus 10 is equal to minus 0.4. So 3x minus 10 is going to be equal to the inverse cos or arc cos of minus 0.4. So let's clear all of this. I'm going to do the inverse cos of minus 0.4 and I get 113.6 degrees. Or should I say 5.8? I'll do 113.58 degrees. 113.58 degrees. And my other one is going to be found by doing 360 minus that answer, which is 246.42. 246.42 degrees. Now I just need to make sure that everything is staying inside this range that I have over here. So using this one as my red one, well, if I added 360 to it, looks like it is still going to stay in range there. So there's my answer that I've got, 113.58. I'm going to add 360 to it, and I get 473.58 degrees. Now, if I added another 360 to that, clearly it's going to be bigger than 530, so I'm not going to do any. And just to show you, if I took 360 degrees away, it obviously goes below minus 10. Okay, so the other value that we had is 360 minus that, which was 246.42. Let's do that one in the green, and I'll actually just move this across so that actually it's not going to work. So we've got 246.42, and I'm going to add 360 to that, and I get 606.42, which goes bigger than the range, so we can't use that one. But maybe if I take away 360, would it still be in range? No, it's also too far away. So actually there's only going to be 3 here because either side of this one is going outside of the range. So we just need to finish up by actually coming up with our final solutions for these. And the way that we're going to undo this to go from the 3x minus 10 to the x is the first thing we're going to do is we're going to add 10 to the values. Then we're going to divide by 3. So let's go all the way back to my 113 one. Let's go here and clear this. Okay, so we've got my 113.58. I'm going to add 10, and then I'm going to divide by 3. So I've got 41.2 degrees. Now I shall do my next one, which is 246.42. So right, it's on that side actually now. 246.42. I'm going to add 10, press equals, and then divide by 3. And I get 85.5 degrees. And then what I'm going to do is my last, which is 473.58. I'm going to add 10 to it, press equals, and divide by 3, and I get 161.2 degrees. So I've got 1, 2, 3 solutions for this. Now, before I check the mark scheme, I'm actually going to check it on. I'm going to check it on Desmos rather than using my calculator because not all of you have the graphics calculator. So I've got the cos of 3x minus 10. So I've got the cos of 3x minus 10, and I want to know when it is equal to minus 0.4, and I think the range was just between 0 and 180. So where is 180? 180 is here. So I've only got 1, 2, 3 solutions. So we've got 41.2, 85.5, and 161.2, which is the 3 ones that we had here. I'm just going to confirm that from the mark scheme as well. 41.2, 85.5, and 161.2. Okay, so there's quite a lot of marks in this question. I'm not sure there would be so many in the new specification. The only mistake I've seen people making this in the past is that they have gone to this first stage here, and when they found the first one, they've added 10 and then divided by 3, and then they've used all of the patterns about adding on 360 and doing 360 minus and things like that. You really, really need to make sure you find all of the solutions, and then the last step that you do is manipulating them to change it so that it is x equals, or Okay, so you're going to do exercise 10E for me, and we're doing really well on this topic. Okay, bye.